Hey everybody, welcome to Programming with Benud. This is Benud Iqbali, and in this video tutorial, we're gonna explore design patterns in Python. For this video, I'm assuming you're already familiar with Python basics, the language, the syntax, the concepts like OOP in Python, classes, functions, methods, stuff like that. In this video, we're gonna focus on creational patterns, including abstract factory, singleton pattern or Borg idiom, builder, dependency injection, factory method, lazy initialization, and prototype. So let's go. Okay, so let's start with the abstract factory pattern. By definition, the abstract factory pattern is providing an interface for creating families of related or dependent objects without specifying their concrete classes. So to implement this pattern, first we need to import the ABC or abstract base class and abstract method decorator from the ABC module. Abstract base classes provide a way to define interfaces, and with abstract method decorators, classes cannot be instantiated. This example is about creating products. So the abstract factory interface declares a set of methods that return different abstract products. These products are called a family and are related. Products of one family are usually able to collaborate among themselves, and a family of products may have several variants, but the products of one variant are incompatible with products of another. So this is the interface. Concrete factories, on the other hand, produce a family of products that belong to a single variant. Note that signatures of the concrete factory's methods return an abstract product, while inside the method, a concrete product is instantiated. As you can see, each concrete factory has a corresponding product variant, and each distinct product of a product family should have a base interface. All variants of the product must implement this interface. Concrete products are created by corresponding concrete factories. Product B is able to collaborate with product A. The abstract factory makes sure that all products it creates are of the same variant. The product B2 is only able to work with product A2. The client code works with factories and products only through abstract factory and abstract product. The client code can work with any concrete factory class. So let's run it and see the results. Okay, let's move on to the next pattern. Okay, the next pattern is called the factory method. Let's see what the factory method is about. By definition, the factory method is defining an interface for creating an object, but let subclasses decide which class to instantiate. Factory method lets a class defer instantiation to subclasses. Like the previous pattern, we need to import the ABC or abstract base class and the abstract method decorator, because we need to create interfaces. So just like the previous pattern, abstract factory pattern, here we got the creator class that declares the factory method that is supposed to return an object of product class. The creator's subclasses usually provide the implementation of this method. The creator may also provide some default implementation of the factory method. Also, creator contains some core business logic that relies on product objects returned by the factory method. Subclasses can indirectly change that business logic by overriding the factory method and returning a different type of product from it. So as you can see in here, we call the factory method to create a product object, and then we use the product. Okay, so enough with the creator class. Concrete creators override the factory method in order to change the product type in the result. And the product interface declares the operations that all concrete products must implement. Concrete products provide various implementations of the product interface. And the client code works with an instance of a concrete creator via the base interface. As long as the client code keeps working with the creator, you can pass it any creator's subclass. Okay, so let's run it and see the results. Okay, let's move on to the next pattern, the builder pattern. By definition, the builder pattern is separating the construction of a complex object from its representation so that the same construction process can create different representations. So again, we have to define interfaces. So we need to import the ABC and abstract method decorator. The builder interface specifies methods for creating the different parts of the product objects. By the way, you're noticing why we're using the property decorator, right? If you're familiar with getters and setters in any other language, this is how we create getters and setters in Python. So this is the reason. Okay, let's move on to the concrete builder class. The concrete builder classes follow the builder interface and provide specific implementations of the building steps. Concrete builders are supposed to provide their own methods for retrieving results. That's because various types of builders may create entirely different products that don't follow the same interface. Such methods cannot be declared in the base interface. And by the way, we're using the builder pattern only when our products are complex. Unlike the other creational patterns, different concrete builders can produce unrelated products. In other words, results of various builders may not follow the same interface. The director is only responsible for executing the building steps in a particular sequence. The director works with any builder instance that the client code passes to it. The client code creates the builder object, passes it to the director, and then initiates the construction process. The end result is retrieving from the builder object. Okay, let's run it and see the results. Okay, now we're gonna move on to the next pattern. The next pattern I wanted to cover is called the singleton pattern, but here's the thing. I don't think that's a good idea because there are some costs and risks about using this pattern. For example, singletons violate some principles and rules. So we're gonna focus on singleton first, and the reason why we shouldn't use this pattern. By definition, the singleton pattern is is about ensuring a class only has one instance and provide a global point of access to it, or global state. And that's why we avoid using this. There are some reasons for that. For example, singletons violate the single responsibility principle. Also, the singletons are difficult to test. And because of these drawbacks, we consider singleton to be an anti-pattern. So instead of singleton, we can use the Borg idiom or the monostate. For more information about Borg, you can read this question and answer or learn more about this pattern or idiom in this article, Avoiding the Singleton Design Pattern with the Borg Idiom by Alex Martelli. Okay, so the Borg idiom or the monostate pattern is a way to implement singleton behavior, but instead of having only one instance of a class, there are multiple instances that share the same state. In other words, the focus is on sharing instance identity. To understand the implementation of this pattern in Python, it's important to know that in Python, instance attributes are stored in an attribute dictionary called dict. Usually each instance will have its own dictionary, but the Borg pattern modifies this so that all instances have the same dictionary. In this example, the shared state will be the dictionary shared between all instances. Okay, let's run it and see the results. Okay, let's move on to the next pattern. Okay, the next pattern I wanted to cover is dependency injection, but unfortunately I decided not to cover it in this video because it takes more time to explain everything about it. I mean more than 2 or 3 minutes. So I will cover dependency injection in another video. Sorry about that. Okay, the last pattern I like to cover is the prototype pattern. This is the easy one. So by definition, the prototype pattern is specifying the kinds of objects to create using a prototypical instance and creating new objects by copying this prototype. So in other words, it's about this pattern is about shallow copy and deep copy. So I guess we can skip this pattern. Because this is the easy one. So don't forget to learn more about these patterns, and thanks for watching.